10.3, prove your parallelogram. Write the equation of a line parallel to y equals 2x plus 3, passing through negative 4, comma 1. All right, so if I have a line that's parallel to this line, the one thing I know that's going to be the same is the slope. We just showed that slopes of parallel lines are equivalent. So I'm going to rewrite this equation now with the same slope, but what I don't know is what this y-intercept is going to be. So I'm going to put b there. I do know this line passes through negative 4, comma 1. So what I can do is I can plug in the coordinate to my equation to get 1 equals 2 times negative 4 plus b, negative 4 in for 1, 1 in for y. I'm sorry, negative 4 in for x, 1 in for y. Now I'm just going to simplify. 1 equals negative 6 plus b. I don't know why they always insist on putting negative 6 in problems where you have a b. I think it's a little confusing, but and we just get 7 is equal to b. So my equation is y equals 2x plus 7. All right, graph both lines described in the previous question. All right, so I'm going to make a quick graph. I know my y-intercepts are really are positive, so I'm going to try and I don't really need all the stuff down there, the third and fourth quadrant. All right, so first graph is 2x plus 3. So that's y-intercept of 3, 1, 2, 3. Then my slope is 2x. So if that's rise over run, it's really 2 over 1. So I'm going up 2 over 1, up 2 over 1, up 2 over 1. If I want to go in reverse, I'm going down 2, back 1. And that's really enough lines. Enough dots, I mean, for me to plot this whole line. All right, next. Y equals 2x plus 7. 1, 2, 3, 4, 5, 6, 7. Same slope, up 2 over 1, or down 2, back 1, down 2, back 1. The important part is when you're reading it left to right, you read up 2 over 1, up 2 over 1, up 2 over 1. All right, there's my two parallel lines, and I'll call this y equals 2x plus 3, and this one y equals 2x plus 7. All right, number 3. Draw a parallelogram using the two lines you graphed and using 4, comma 1 as one of the vertices, negative 4, comma 1. Okay. Looks like, oh my God, that's embarrassing. I made a mistake. All right, 2 times negative 4 is negative 8. So that's gonna change up everything. But that's okay, we make mistakes. This will be 9. Fix this 9. That's gonna change my y-intercept to raise it up 2. All right, but it's good that they asked another problem. It shows clearly I made an error. All right, so y equals 2x plus 9. All right, so we want to follow that slope back to down 2, back 1, down 2, back 1, down 2, back 1. All right. Great, now I can see the point, negative 4, comma 1 here. All right, so if I'm going to make a parallelogram, right, by definition of a parallelogram, we say opposite sides are parallel. Oh my God, it's like the world's smallest spider. Okay. Great, so if I'm going to make my next pair of sides in this parallelogram, I just have to make sure that those sides are parallel. So the easiest way for me to connect these two sides, I'm looking right here. And the only other part that I need is another line opposite that now that's also parallel. So if you look here, I really could choose from quite a number of lines. I really could actually connect anything on these horizontal lines here on my grid, and that would be parallel. So I'm just going to pick, this one looks pretty simple. Prove that your figure is a parallelogram. All right, so to prove something's a parallelogram, like I said here, I just have to prove that opposite sides are parallel. So I already know that. Let's actually label this A, B, C, D. So what I want to show that AB is parallel to CD. That's one thing. Then I also want to show that BC is parallel to AD. All right, and how I'm going to do that is I have to show that the slope of line segment AB is equal to the slope of line segment CD. Same thing here. The slope of BC must equal the slope of AD. So this is pretty easy for AB. I already know the slope of AB is 2. Already know the slope of CD is 2 because the equation is 2x plus 3. So these slopes are both the same. Now for BC, I'm going to have to find the rise over run. So let's see, rise over run. So if I'm going from B to C, I'm rising 0. I'm running 3. If I'm going from A to D, I'm rising 0 and I'm running 3. So these two slopes are both 0 because 0 divided by anything is just 0. So that also works. So since opposite sides have the same slope, they must be parallel. Great, and that's all that was. And we know that opposite sides are parallel in a parallelogram. Both pairs of opposite sides are parallel. The quadrilateral is a parallelogram. All right, are you ready for more? Prove algebraically the translation x comma y, where x is increased by p, or we add p to x and add q to y, takes this line to a line with the same slope. Well, we showed him to do now that translations result in parallel lines, but let's prove it. So if I'm starting off with y equals mx plus b, if I'm adding q to y, my new line is going to be y plus q. And if I'm adding p to x, this is the tricky part, I need to add p to x like this, because if I just were to add p like right here, that would be adding p to m times x. So I want to add it directly to x, so I have to isolate it. And we've got our b here. So using the distributive law, we get mx plus mp plus b. These are really just constant terms, right? There's no variable involved. I know we have q, b, and m, but when we actually have a line, all those values are going to be numbers. So these are really representing some number here. Now to get this back to slope-intercept form, I have to get y alone, so I'm going to subtract q. And I'll do that from both sides, and I get y equals mx plus, and I'm going to put all this in one big parentheses, mp plus b minus q. This number here is my y-intercept. M is still my slope. So since my slope didn't change from the original equation, we can say that these two lines are parallel. Y-intercept is different, but we need that to be true. If lines have the same y-intercept, that means, and the same slope, that means they lie right on top of each other, right? So that wouldn't be parallel, that would be the same line. These have different y-intercepts, same slope, so they must be parallel lines. All right, have a great day.